Looks like we're live. Hello everyone and welcome to yet another Azuzin session. I hope you can hear me well. So I'm probably a little bit far away from my mic. Let's make a little bit of an announcement and officially start the stream. So of course Discord. Okay, that's cool. Red Circle, live on Twitch. And what are we doing today on twitch.television? We're doing graphics in C on Linux without OpenGL. Isn't that exciting? I hope it sounds exciting enough that you will click on that stream and watch an epic software development with Zozin. Didn't ping it died. Anyway, so I just wanted to ping everyone who's interested in being pinged. And there we go, the stream has been officially started, has been officially forwarded. So today we're going to continue developing Olivet, which is a graphics library that we've been developing for quite some time, I think like 3 or 4 months already. Right, so you can find this thing in here, and I'm going to also put that in the description. I think I forgot to prepare my description file for today's stream. Yeah, I did in fact forget to do that. So 07 12 2022, right? So this is references, and this is the source code, right? And also I usually put some sort of a title in here so I can later go back and recall what stream this thing belongs to. There we go. All right, so yesterday we were working on bilinear interpolation. That's right. So if we take a look at one of the examples, right? So let me rebuild demos, specifically squish demo for SDL, right? So I'm rebuilding very specific demo. And if I run this specific demo like so, you will notice, right, so that we have this pixelated situation going on, even though it kind of sort of anti-aliased, but it's anti-aliased with huge pixels. This is because in reality it's not anti-aliased, and anti-aliasing comes from the image itself. It's the image itself that provides anti-aliasing, but it's not enough when you actually stretch it, so it still looks a bit pixelated. On the previous stream we explored how to do so-called bilinear interpolation that allows you to you know, smooth it out, smooth the pixels out. So let's actually see how it's gonna look like if we enable the bilinear interpolation. So if I take a look at the demo and take a look at the squish, and here we just do blend, but if we do copy bilinear, I think this is how I do that, and then I rebuild this specific example super quick and then just run this specific example, you will notice that it's not like it's much smoother now, right? All of the lines are sort of like interpolated and stuff, right? So you can see how smooth it is now, right? And we did that specifically for rectangular textures, right? Specifically for rectangular textures. But what's interesting is that when I'm developing this library, there's two kinds of functions that start to emerge during developing this library. Rectangular functions that work with specifically axis aligned boundary box, right? Rectangles that are not rotated, right? So their boundaries are axis aligned, right? And another kind of functions, the ones that work with triangles, right? And they kind of like have a lot of symmetry between them, right? They have a lot of symmetry. Like one stuff that is implemented for rectangular functions, it's also have like a analog in a triangular ones. And this is one of those situations, right? This is one of the situations. We implemented bilinear interpolation only for the AABBs, but now we also have triangles that also can do the textures. For instance, if I do triangle tech, I think triangle tech 3D, I think something like this. Don't quite remember. So I think I don't have everything built at 3D tech. Right, it's called 3D tech SDL. Right, as you can see, here we have a textured triangle, right? So a textured triangle, but you can see that it is not properly interpolated. It's actually kind of cool, since it's in 3D space. Their pixels are sort of distorted. You can see that their pixels are sort of like these diamonds. This is actually kind of cool. This is because, yeah, because they're all at an angle or something like that. But yeah, we still need to implement interpolation for the functions that work with triangles to actually get rid of this kind of situation as well. And this is going to be the plan for today, right? So we're going to be basically porting our rectangular bilinear interpolation code to triangles, right? So, and we'll see how it goes. We'll see how it goes. So thank you so much for the subscription, Foidy, for 7 months. Thank you, thank you, thank you. So let me find the function that is doing bilinear interpolation. Right, so here is the sprite copy bilinear. So it's a little bit messy. In fact, the entire library is kind of messy. So if you take a look at the functions of the library, right, it's kind of like a soup of different functions, and I'm doing that intentionally. I'm just basically throwing at this library everything I know about like computer graphics, right, and just see what kind of patterns appear out of that. And then when I throw enough into this thing, I start to actually organize all of that stuff. So right now it's just like it's literally soup of functions. It just doesn't have any system or anything like that. But for instance, as I already mentioned, some sort of a pattern started to emerge. As already said, we're starting to have like two groups of functions. The functions that work with AABBs and similar functions that work with triangles, right? And they're very much similar, right? So they have like a symmetrical situation, just like with bilinear interpolation, but it's just like you have to write specific code for those things. So maybe in the future, I'm just going to come up with a naming scheme to sort of emphasize what kind of group this function belongs to. Is that AABB function or is that a triangle function? Right, so, and we'll see how it goes. Hello, hello everyone, how are you guys doing? All right, so this is where we do bilinear interpolation, right? So we iterate through the pixels and then we calculate the texture position, and then we calculate the interpolation, right? So when we calculate back the texture position, we can actually hit between the pixels, right? And we calculate where exactly we hit between the pixels of the texture, and based on that between pixel position, we blend the colors accordingly to create smooth interpolation, right? So interestingly enough, if we want to do this kind of stuff with a triangle, right? So the function that we use for the triangle is triangle3uv. It accepts the triangle coordinates and then the texture coordinates and the z coordinates to accommodate for distortion because of the projection on the screen, right? Because we have a 3D projection, and because of that, the texture coordinates have to be adapted accordingly. Right, so if we take a look at how this function is implemented, we're iterating through each individual pixel over the triangle using barycentric coordinates, right? And then eventually we compute the texture coordinate, texture x and texture y, right? So as you can see, we have a bunch of computations in here that take into account the projection, the z coordinate, the texture coordinate, and we end up with just two integers, texture x and texture y. Right, and we just grab that pixel and put it into the place where we want to put it, and eventually we have like a textured 3D triangle, right? So, and here we just have to do a similar situation, right? The pixel that we compute back into the texture, so you can clearly see here, right? So it probably hits somewhere between textures as well. Right, it probably hits somewhere between textures as well, and we need to do the same thing. We just need to see where exactly it hits between the pixels, and just blend neighboring pixels accordingly to create this smooth transition. Right, it's pretty much the same thing. We just need to port it to this place. What I'm thinking, by the way, since I'm going to be doing the same thing in two places, maybe it makes sense to actually extract that bilinear interpolation process into separate functions. So in some sort of a function that accepts the texture, the coordinates, including the precise coordinates between the pixels, and this thing should return as the interpolated value. I think that's actually kind of cool idea. Yeah. So that's precisely what we're gonna do. Maybe dumb question, why don't you handle square rectangles with 2 triangles? Because it's a different input, different kind of input. Right, and also performance implications. For rectangles and triangles, we use different algorithms that have different performance. And depending on your situation, right, for instance, maybe you never actually draw anything but axis-aligned boundary box. It would make sense for you to use only axis-aligned boundary box API always and be a little bit faster because you don't have to compute complicated Bayesian coordinates and interpolate too much between the triangles, right? So essentially, it's all about assumptions. Just because you're limited to a certain kind of shapes, you can do more assumptions that actually allow you to improve performance, for instance, right? So it's not about only just a visual part, but it's about like different assumptions and stuff like that. This library is not a black box. That's an interesting thing. I don't like a code that is black box where I don't understand how it works. I just throw data into it and it just outputs back. I know a lot of people kind of comfortable with this kind of thing because they're afraid of cognitive overload. But what I found is that the most flexible code is actually very much open, and you can look inside and understand how certain things works and rearrange certain things in a way that that is more suitable for your task. And this is what this library is all about. Does it make sense? I mean, I tried. Yeah, anyway. If you didn't know English before the last 10 years, how did you code? We have a lot of translated materials to Russian. At least 10 years ago, I don't know how it is for now, but at least 10 years ago, we had a very active Russian-speaking community that was translating a lot of stuff to Russian, right? So, like, I'm not really participating in Russian-speaking community anymore, so I don't know how active they are in translating things to Russian. So, yeah. Actually, 10 years ago, you could have be a pretty good programmer in Russia without even knowing English, right? Because there was a lot of materials like in Russian translated by some other people. Will I get rid of SDL at some point? SDL is not part of the library anyway. It's a part of the demos, right? But it's not a part of the library. Okay, my answer regarding like AABBs and triangles makes sense. Okay, I'm really glad that I managed to explain that because it's very subtle, right? It's very subtle, especially in this modern programming culture where everyone just tries to treat everything as a black box, and instead of going inside of the black box and fixing the problems within the black box, people just tend to throw more code on top and making a bigger black box, right? And because there is this kind of structure of software culture of software development, it's really difficult to justify the things that I'm proposing usually. Right, because I'm all about like stripping off the abstractions and making things simpler, because this simpler thing has less bugs, and actually simpler systems are much more safe because they're simple. You can actually review them and make sure that they're safe, right? So it's kind of difficult to prove that complicated system is safe. And because of this like very persistent culture, I'm a little bit anxious to explain this idea. I'm always afraid that people will just not only not understand me, but instantly reject whatever I say, right? It's kind of, I don't know. All right, so let's continue. How are we going to be implementing this function? So let's call it Olivet's bilinear pixel, right? So we already have something like Olivet's pixel, which is a macro, right? Which is a macro, and it just gets the current pixel. But maybe we need to have something like pixel bilinear, right? But this one is not a macro, so we have to keep that in mind. So this thing is going to return the color of the pixel, right? So we also need to accept some sort of a texture in here, right? So this is going to be canvas. let's call it texture. And this is where it becomes rather interesting, right? Because we don't pass the floating point coordinates, right? So what we need to pass in here, we should pass not a pixel of the texture coordinate, right? We don't really care about the pixel of the texture coordinate. We put a pixel plus the fractional part, right? So let me actually try to draw that and see how it's gonna go. If no one will try to reinvent the wheel sometime in the future, we won't be able to fix the wheels that break. This is actually way more complicated than you think. We, as a humanity, literally reinvent the wheels all the time. I would even argue that reinvent the wheel is actually very bad analogy to software development because, again, humanity reinvents the wheel, literally reinvents the wheel all the time. Every time you make a new vehicle, there are people who literally sit down and design new wheels for that vehicle. Some sort of like a heavy machine vehicle. Like, they literally reinvent the wheel. Why the fuck are they do that? Why can't you just take a wooden wheel from the 1,000 years ago? Why reinvent the wheel? In fact, it's literally a bad analogy because people do that all the time and it's a very useful activity. So it's just a bad analogy that doesn't really fucking hold it against reality because we do that all the time and it's very useful. Without reinventing the wheel all the time, we wouldn't go anywhere, right? Because we won't have the right wheels. All right, so imagine that you have a texture, right? And imagine that the texture is 3 by 3, right? So the function that I'm trying to develop will accept the pixel coordinates, but it won't accept pixel coordinates from 0 to 3 in integer, right? It needs to accept them in float, meaning that you can hit not only just a pixel, but within the pixel you can hit in any place within the pixel, and depending on that place, you're gonna have a different color because the color of the neighboring pixels is going to affect what kind of color you're gonna end up with, and this is bilinear. This is what bilinear interpolation is all about, right? And we need to put floats in there. But we only have integers because we don't do anything with floats in here, right? We pass the product of the current coordinate and the width. So essentially we're working with rational fractions, right? So essentially here we probably need to accept an x and an y, right? An x and an y, which is effectively the product of the size of the sprite and the coordinates, right? The current coordinate within this entire thing. But I'm not kind of sure. And then division W and H, and this is basically the target width and height, right? So it is in fact a target width and height. So there we go. Now what do we have to do? I think that is basically it, and I should be able to just simply copy paste this entire thing. All right, I should be able to copy paste this entire thing and just put it in here. So px py, then this is that and this is that. And in here I simply gonna be returning this thing. Okay, So let me see. So we are trying to build a demo, and specifically we're trying to rebuild the demo squish, right? So, and it doesn't rebuild properly because so instead of text, we're using the word sprite. Maybe I should just call it sprite so I don't have to go through everything in here. Right. Okay, and this one is rather interesting. So we may end up with something that is sort of outside of the texture, right? And we don't really check in here. We sort of expect the caller of this function to check for the out of bounds things. So I'm not particularly sure how to go about this stuff in here, right? How to go about this stuff in here, but we'll see. So what to do? This does not check for out of bounds, but maybe it shouldn't. Maybe it's a responsibility of the caller of the function. I'm just not sure for now, right? I'm simply not sure for now. Okay, and the way we're gonna use this function, right? The way we're gonna use this function is just like this, right? We remove all of that. So Olivet, bilinear, where's the, so it was called pixel bilinear, right? So it's pixel bilinear. We provide the texture, we provide the sprite, and X and Y, W and H, and there we go. So this thing automatically created bilinear interpolation. And now we should be able to actually reuse this entire thing in triangle, right? So we should be able to reuse that in a triangle, hopefully. We'll see how it goes. So nx and ny is basically a coordinate, but multiplied by the width, right? Multiplied by the width. And width and height is a target, target width and target height, which is rather interesting, But essentially we can just treat this as a thing by which you can divide all of that stuff. Yeah, so you basically pass like a fraction. Yeah, you basically pass like a fraction in here. Okay, that's cool. But without OpenGL, do you mean you're making your own software renderer? Yes, that's precisely what I do. You can find the demos of the thing that I'm doing in here. And this is kind of the thing that we do. This is not OpenGL. This is actually rendered pixel by pixel on the CPU. We even have a little bit of a 3D because projecting 3D onto 2D screen is rather simple. It's just a simple formula. So you can do that. We can do some, texture transformations and stuff like that. And we can have this kind of stuff as well, right? So rotating textures, textured triangles as well in 3D space, some models. As you can see, we have a model, and we even have like a Utah teapot. So it's a little bit slow, but again, this is because it's on CPU. And also on the laptop that I'm streaming from. So I'm running all of that on a CPU on a 10-year-old laptop plus OBS that is currently streaming into the Twitch. So that's why it's a little bit slow. So it's dropping some frames in here. But when I'm not streaming, it's actually rather fast. So then you can also check on your machine, right? This is video or WebGL. This is not a video and this is not a WebGL. It's neither video nor a WebGL. It is rendered pixel by pixel on a CPU. To sort of demonstrate that, I can show you the same demo, but it compiled specifically for the terminal. Right, so since it's rendered pixel by pixel into the memory, we can take those pixels and we can display them anywhere. For instance, we can display them in the terminal, right? So I can do teapot 3D and it's terminal. Yeah, there we go. So this is the same demo. This is absolutely the same code, but it's rendered into the terminal, right? Because we're rendering that into the memory, so we can always take that piece of memory and just turn it into a terminal ANSI escape codes that add colors and stuff like that. This is terminal, right? This is terminal, right? It just like refreshes all the time. So I just do that in the terminal. But it's the same code. So the code of the demos is extremely portable, so you can compile it as a native Linux application or as WASM. It doesn't really care. It doesn't really care in what environment to execute and stuff like that. We also have a native version, right? So where I can just use SDL. In SDL, it's a little bit faster, right? Because it doesn't have to go through the browser and stuff like that. This is a native application. Right, but this is SDL without using OpenGL or anything like that. We're rendering that into the SDL texture. Since it's pixel by pixel, I'm planning to use CMD or multi-threading later on. Yes, I do plan. In fact, it's kind of disappointing with modern compilers these days. I was trying to look what can I improve with CMD, and I looked at some of the functions, and a lot of them were automatically vectorized by the compiler, so it's kind of like it would be kind of cool to like use CMD directly, explicitly, just to learn how to do that. But it's kind of like these days the compilers are so smart, they just do that for you. So yeah. All right. So what we're working on right now, we're working on a little bit of a bilinear interpolation, because as you can see, some of this stuff is a little bit pixelated, right? So we're trying to reduce the amount of pixelation. Yeah, that's what we're working on right now. We're working on the bilinear interpolation. We already have bilinear interpolation. I think we even have an example that demonstrates how it works. Yeah, bilinear interpolation. So expect, there we go. So we can even zoom in, and you can see the difference between them. So this is no bilinear interpolation, and this is bilinear interpolation. So, but this is only for AABBs, right? So we developed that only for AABBs, axis aligned boundary box, that's what it stands for. But now we're developing that for the triangles, right? Because we can also have the rotating triangles and whatnot, and they access the texture slightly differently. So we are adapting existing code for the triangles. That's what we do. Okay, and bilinear interpolation is actually a rather cool technique. I really like that. Okay, so UV. So here is the function that does the thingy-majingy. What I'm thinking is that how can we even do that? How can we even do that? Well, we kind of technically already do all of that. Right, we kind of technically do all of that. So what we need to do, so here we can do something like this, right? We can kind of do something like this. So texture, we in texture U, and we effectively end up with the integer, but this thing might be actually like very, very small. This thing might be This is kind of cool. So that means for these specific textures, we'll have to turn this into a float. That is very cool. Right, so since we're already kind of working with the floats in here, we have to continue working with the floats like that. There we go. So, and if it's less than 0, we can always bring it back to 0. If this entire thing turns bigger than the width, right, we might as well actually convert this into float. Yeah, might as well convert this into float. And just put that stuff in here. Why did it copy paste it twice? I have no idea why it copy pasted twice. But yeah, there we go. So we have a bunch of floats and all of that in floats. But now we want to be able to do the bilinear interpolation, right? We want to be able to do Olivet's pixel bilinear. We want to provide the texture, but now we want to be able to provide the texture like this, right? But since this thing accepts only floats, right? Since it accepts only floats, we need to convert that into the fraction, which is kind of like too much, in my opinion, of the how to say that, of the conversion. Maybe we should create like a second version of this function that accepts the texture coordinates in floats instead of integers and fraction. Olivet's pixel, yes, that's right. How do you install the software on Linux? You don't install the software on Linux, you develop it from scratch right on your machine. Right, so that's the Linux way of installing software. You write it yourself from scratch on that specific machine, and it works only on your machine. How much Bitcoin for Python interpreter in Haskell stream? 1,000 Bitcoins, and I'll consider doing that, but I can't, can't promise that. A Python interpreter in Haskell, it's kind of boring, to be fair. I suppose you just, if you want to implement Python interpreter, you would just implement it in Haskell the same way you implement it in any other language. Right. Haskell is not that different of a language. It pretends to be special. It only pretends to be special and very academic and very high level and very elitist. But when you start developing like an actually useful software in Haskell, it looks like a pretty shitty Python. Honestly, with static typing. It's just like it's a very boring language when it comes to like actual software development. And you can only realize that by trying to do the actual software development, and it's just like a lot of people instantly get disappointed in Haskell. It's just like, oh, it's just like, okay. All right. All right, so let me see. One of the things we can do. Oh, this is kind of cool. Believe it or not, we have two coordinates, right? So imagine that we have a texture X, and let's imagine that it has a value 69 for 20, and Y has a value 2342, right? Or maybe, I don't know, like 69, whatever. Right, so the integer part shows you the specific pixel you're in, right? And the fractional part shows you where exactly within the single pixel you are, right? It's a fractional part of the pixel, right? We have these float things, but the bilinear thing accepts the fraction, right? It accepts, instead of float, it accepts the actual like rational fraction, like a/b. Right. How can we convert all of that there? Well, we can pick a thing, right, which is going to be called precision, right? Precision. And let's say the precision is going to be 100, right? So, and then when we pass this thing into the bilinear interpolation, we're going to multiply all of these things by 100, right? And we're going to end up with values like this, right? And then we're going to pass the precision as the denominator into the function, and this is how we basically convert that into the rational fraction. So essentially in here we can choose the level of precision we can go with, right? With AABBs, since we already do everything in integers, we can't really choose the precision. It's whatever precision depending on the size of the target rectangle. Here we can actually pick a precision, but it's still limited by the precision of the floating points, so we'll have to keep that in mind. But apart from that, it's pretty straightforward. Okay, so let's actually give it a try. I'm gonna literally just create precision, right? So this is gonna be an integer. Right, and when we're passing this thing in here, I'm just multiplying that by the precision, Right. Precision is an integer, texture is a float, and then the argument is an integer again, so it's going to convert it back. And then we just pass the precision as the denominator, and there you go. So that should give us the expected result. That should kind of give us the expected result. And let me actually put it like that. Maybe I'm gonna, I don't know. Let me put it in here. So is that a good thing? Probably. Okay, let's try to Emacs. Let's try to rebuild the entire thing. So it doesn't like what's going on in here. Did I accidentally remove the precision? Yeah, I think I accidentally removed the precision. It's kind of strange. But anyway. Okay, cool. So, but I rebuild only the squish. I wanted to rebuild the texture 3D example, right? So where is that? So it's a 3D tag, right? Triangle, 3D tag, right? So let's rebuild that specifically. Seems to be compiled so far. Don't see any problems. Let's rebuild specifically SDL, right? Because that's what we're gonna be running in here. And let me just go ahead and run this entire thing. Triangle 3D tech SDL. So what do we have? All right. Do you guys see interpolation? So yeah, we can take a look at the original thing, right? We can take a look at the original thing. What I'm going to do, I'm gonna just go to the build folder. Right, I'm gonna go to the build folder, find the demo, 3D tech. So here is the SDL, and I'm gonna actually say bilinear, right? So this is the bilinear SDL, and I'm going to disable that thing, right? I'm gonna disable that thing. So let me find the original code that we had. So this is the original code, and I'm gonna go in here. So where is the file? Here it is. Here's the file, right? So we're gonna do something like if one, else, right? And if, and I'm gonna rebuild this thing one more time, right? So it doesn't compile properly because why? This thing is not an integer. We can make it an integer. Not that big of a deal. Not that big of a deal. Let's make it an integer. And there we go. So this is what we had before, right? So this is what we had before, and now what we have is triangle 3D tech bilinear. There we go. So this is what we have now, right? So this is what we had before, right? This is what we had before, and this is what we have now. So it's a little bit slower, right? Because of all of the convergence and stuff like that, but we managed to actually convert, you know, the code that we use to do this thing. It's kind of like this specific demo is kind of lame, in my opinion, right? Because it uses some sort of a texture, but it's really unclear what its texture is all about and stuff like that. Maybe we should use like two textures in here, maybe like actual textures from a 3D game, like a texture of a wall, like a stone wall or cobblestone wall, and another one a texture of like a wooden wall, like wooden planks and whatnot, and just like do the intersection between them to make it look good, right, or interesting. Because right now, like, what the fuck are we demoing in here? Like, what's so special about this thing here? It's kind of lame, don't you think? It's kind of lame in my opinion. All right, so maybe we can work towards that. Maybe we can work towards that. So, does anyone have any on-topic questions? Probably not. All right, let's make a small break. I want to make a cup of tea because I ran out of tea. So I think I want to create two separate versions of this function. The first one that doesn't use the bilinear interpolation, and the second one that does use. Doesn't use and does use. Okay. So let me go ahead and just see. 3 UV, right? So I'm gonna put this thing in here, and this one is going to be bilinear, right? So this is bilinear. Triangle 3 UV. So this one is already bilinear for sure, right? So it's already bilinear. And then let me make this the main stuff. And another version, the one that does use, and the one that doesn't use the bilinear interpolation. Right. It's a little bit of a copy-paste code, but again, it's needed to actually then later notice the patterns to reduce them and stuff like that. Right, so it's totally fine to duplicate code, right? I use that as a way to gather information on what's needed and what's not needed. So that's basically how I do that. So this one, okay, so this one becomes integer, this is an integer, and then I'm gonna move this thing to here. This becomes size t. This becomes size t and size t. All right. So maybe I'm gonna actually separate these things. So something does not particularly work because if I go to semicolon, that's fine. It's totally fine. That's precisely what the compiler is all about. So now we're using the version without the bilinear interpolation. Let me find 3D. Did I already close that demo? I feel like I already closed it. I need to have it open somewhere here. So 3D texture, where is 3D UV? 3D UV bilinear. Alright. Okay. So in here we have the bilinear interpolation. Yeah, there we go. So this is two separate functions, but there is another demo that uses textures. It's called triangle text, but it doesn't use these specific functions. As far as I know, this is one of those demos that iterate the pixels of the triangle directly without any Olivet's functions. Yeah, there we go. So this is what we have in here. Yeah, and the way this thing works, if I remember correctly, triangle tech. Yeah, we directly iterate. Oh no, look at that. No, we're still using this thing. It's just like, oh, we just set z to 1 to basically indicate that we don't have any distortion, like 3D distortion. Okay, so that's actually kind of funny. Okay, so this is bilinear, and if I can just like straight up enable bilinear interpolation here, and it will, and it's interpolated. Yeah, so okay, that's pretty cool. It's straight up interpolated. So let's actually rebuild all of the demos, right, and see how they look like in WASM, right? So triangle 3D. So I think I want to enable like bilinear interpolation for all of the demos, right? I think it's gonna be a good idea. So demos. Let me see. So dots, model, squish. Here we use bilinear, which is fine. Triangle 3D texture. So UV uses bilinear. 3 UV. Yeah, there we go. 3 UV. So triangle doesn't use any texture. Triangle texture. Okay, so all of them are already using bilinear. So let me remove the build folder just to build everything from scratch, and let's just go ahead and like literally rebuild everything. Okay. So how's it going, everyone? So I'm just waiting until it builds. I'm still using French press for tea. No, I'm actually brewing tea just in a cup, actually. Thanks for Python streams, you're welcome. Thanks to whoever suggested the topic. I forgot their name, unfortunately. Right. Okay, so we rebuild everything, and let me just run this entire thing. Obviously, with bilinear interpolation, it's a little bit slower, but I'm gonna address that later. Right. There we go. Okay, so here we have that. And here is this thing with bilinear interpolation. Okay, it actually looks much nicer. I really like how it looks like. Okay, and oh my god, this is actually so cool. I really like that. And overall, yeah. There we go. So okay, speaking of the like different textures in here, right? So open game art something something. I think that's the website where we can have public domain textures. Thank you so much, Bufford0014 for Twitch Prime. Thank you, thank you, thank you. Is it much slower? Looks slower. Easy? I don't think it's much, but it is slower. Hard to tell, actually. Anyway, so cobblestone. Okay, stone. Oh, this looks nice. I really like this one. Is it public domain? It's CC BY. Okay, so can we find purely public domain? I'm interested in purely public domain because I'm narcissistic prick and doesn't want to credit anyone. It's not because of that, right? So because it's just like wanna make myself as little amount of work as possible. Okay, maybe something with attribution. Oh, this one looks nice. Okay. Ooh, this looks cool. It's like magma stuff. Okay, so can I download? So credits. So I'm still gonna like put that in the credits just to like have a link when if I need to go back. All right, so I'm just wondering which. I forgot how to use computer. Okay, it's so inconvenient. Why can't I just save it in here? So I can't save it in here. So I have to kind of click on these files, and it's not clear for me which files is which. It's so weird. It's such a weird system. Wait a second. I want specifically this thing, and okay. It's so bad. Oh my god. Okay, I'm sorry. So old stone. So generally in terms of UI, when I see something, I want to click on it and I want to download exactly that. Like with this kind of system where by seeing this thing, I cannot click on it and download it, it's kind of difficult for me to understand like what name corresponds to what. Luckily they have the third thing in here where I can click, but it's just like generally very confusing. I'm sorry for ranting about that, but it's just like a very confusing thing. Ooh, I'm sorry. Okay, so let me copy paste it in here. And it's actually kind of huge. If we take a look at this thing, right, it's 1,000. My god, I definitely need to convert this entire thing. So old stone, let's resize this entire thing to something like 120, right? So old stone 120. All right, so that looks a little bit better, I think. Right, and it's actually much smaller, but it's not that small compared to the rest of this thing, but anyway. So one of the things I want to do, I want to basically build this asset into a C file so I can bake that asset into my demos, right? So old stone to 120, right? So it was old stone, right? Assets, yeah, let me actually keep it like this. And this is assets old stone. There we go. So now I can do no build assets. Right, let's take a look. So the old stone has been built. Here it is. And if we take a look at this entire thing, here it is. Here are the pixels of this specific image, so we can bake that image into the demo. Right, so now I'm gonna go to one of my demos right in here. Demos 3D texture. Right, so this is a 3D texture, and we're using sodium pogue as the texture. Right, so let's actually replace sodium pogue with old stone, and see how it's gonna go. Maybe, you know what? I think in nobuild I should actually call this thing just old stone C, not 120, right? Because I just don't want to have like a dash in the name, so I don't think it's particularly great to have that. Anyway, okay, so now let's rebuild a specific demo, which is triangle 3D texture, right? So, and it doesn't really work properly because why? Oh yeah, because in the original demo, the name of the variables is not exactly what I think it is. Yeah. Oh, it's still using word sodium cup because I copy pasted the code. Okay, so that's fine. So essentially, what I have to put in here, I have to put old stone. There we go. So hopefully, if we rebuild the assets, so let's first rebuild the assets. Okay, the assets has been rebuilt. Let's rebuild the demo. And the demo seems to be built correctly. Well, it's not finished, but it's already good progress. Right, and let's just try to run this entire thing. Demos, triangle, 3D texture, SDL. And that's what we have in here. It's kind of weird. Right, it's kind of weird. It's kind of like... Yeah, it is definitely weird. But I suppose this is because of the UV coordinates. Right, so we probably need to fix the UV coordinates. Let's actually give it a try. That's pretty cool. So let's actually do the second thing. What's going to be the second texture in here? Alright, so cobblestone, wooden. Right, so let's take a look at wooden planks. So this is CO. Oh, this looks alright. I think I can use that. Wooden crate. Though I would probably go for something a bit more realistic, if you know what I mean. This doesn't really look right. What about this one? It's too huge. I don't want to spend time cropping. It would be nice to have something that I can just download and just copy paste into my stuff. Don't like any of this. Okay, so maybe let's just use another stone, but with a different color, like this one, for the contrast. Okay, so let's download this then. This one, lava stone. Okay, so let's give it a try. I'm gonna go to the downloads. Lava stone. Where is the lava stone? Lava stone. There we go. So let's put that into the assets. And let's also resize this thing. So let me see. So probably have to do convert, right? So let's do convert. Convert, please. Resize 120. Lava stone 120. There we go. So we have that. And no build. Let's query replace. Old stone with lava stone. There we go. And no build assets. There we go. So it seems to be it build everything. Okay, that's cool. Now in 3D tech, right? So we're also gonna include lava stone, right? You can see both of the assets are included in here. Right. And let's also do it like that. So now we have old stone and lava stone. cool. You know, I think we really need to fix the UV coordinates, but I forgot where we put UV coordinates actually. So this is a triangle Z. I suppose these are the UV coordinates. They're kind of lame. So this is the triangle, this is UV. So if I remember correctly, P1 is... Oh man, I don't remember. 0, 7. So in terms of Z, this is just Z. Alright, Z plus, okay, that's fine. One leg, this is another leg, and T minus. I suppose you can think of this thing as the left leg, and this is the right leg, and they're all both at the bottom, and this is the top. Okay, so that makes sense. We can work from here. Right, we can work from here. If this is the left leg, that means it's a 0, 1. Oh, that's why it is... Okay, so they're precisely what I wanted, but they were just swapped, I see. So that actually explains why it was sort of like weird, but yeah. Nobuild is a Python script. No, it's actually a C program. Right, it's literally a C program. I'm building C with C. Yes. Building C with C. It's actually kind of cool. Believe it or not. It's a very interesting idea. Very innovative idea that I came up with like 2 or 3 years ago. For how long time ago I came up with it? But anyway. So I suppose, yeah, like 2 years ago. Yeah, I came up with that, but 2 years ago. So people usually build C projects with like shell scripts, make, CMake, usually some other tool, right? Some other tool, which is kind of weird, right? We're building C project written in C. Why is it not enough to have a C compiler to build an entire C project? In my opinion, there should be only C compiler that builds the entire, C project. And this is what it's all about, right? So you have a C program that builds the rest of the project. The first thing you have to do, you have to bootstrap it, right? So you have to build your nobuild script, like so. You first bootstrap it, and then you run your nobuild script, and it builds the rest of the things. And you don't need make, shell, CMake, any other things. Like the only thing you need is C compiler. C compiler first compiles the code that will build the rest of the things. And you can actually bootstrap that in several stages. Who said that the program that you bootstrap doesn't build more code that builds even more code and builds even more code? You have a C compiler, and C compiler is a C language is Turing complete language, and it can interact with the operating system and can do actually more than any of the Python scripts and stuff like that. It's just like nobody's doing that. And I'm doing that. Alright, as you can see, I just rebuilt the entire project with C code. So all of that is printed by C code. Right? C code just runs other compilers and stuff like that. Anyway, so let me actually see. So it complained that I don't use old stone. Oh, it complains that I don't use lava stone. Okay, so let me run demo triangle 3D texture and ooh, this is fucked, but this is actually kind of cool at the same time. Look at that. Yeah, it's probably something with the Z-axis. Alright. Something with the Z-axis. Oh, I think I know what the fuck is going on. I still need to keep this thing. What I just have to do is replace 3 back into 2 and 2 back into 3, something like that. I think that's what needs to be done here. So let's rebuild the demos, triangle 3D tech, SDL. Okay, cool. Right, and then build demos triangle 3D tech SDL. Is it working? It's kind of working, but it's still fucked up. It's still kind of stretched, but maybe it's not. If I bring back Tsoding Pog, right, so maybe this is something with the old stone itself that kind of does that. Tsoding Pog. Old stone. Where is the old stone? And let's just keep it like that. Stone, Tsoding Pog. There we go. It's kind of cool that I can actually swap these things. I can say, okay, use Tsoding Pog now. And let's see. Does it make sense? It kind of makes... Oh yeah, because it's kind of on the side. Yeah, but I guess that's fine. Alright, so this is the old stone, and let's take a look at the second triangle in here. Right, so we're doing the second triangle. Yeah, isn't that Pog? Isn't that Pog? I think it's freaking Pog. So I suppose what I want to do in here is just this. Alright, I'm gonna put it in here. But we have to do OC2. We're rendering that to the second thing in here. I'll definitely need to clean it up, but yeah. So lava stone. Okay, that's cool. Does it look like a cool demo? It looks like shit, to be fair. I wonder why. Oh yeah. So let's actually rebuild everything. Right. So we have unused texture. Well, I'm gonna keep it for now because it's for testing purposes anyway. Yep. Rotating textures. Here they are. So this is in the web browser. Kinda looks cool. I wish I could fix the distortion of the texture. But I don't quite understand what causes it. Because the coordinates... Alright, the coordinates that we use. So 0, 1. So 0, 1 is that one. And then... Oh, this one is... I think this thing has to be 1, 1. Yeah, because it's... Of course, obviously, it's not like that. Okay, so let's actually start with this, the old stone. Right, so let's try to fix that with the old stone. Triangle 3D tech. Build demos. Why did you go there? Oh, because I'm here. Okay, cool. So I think it will fix the hopefully. Yo, look at that! Perfect texture. I was right. I just fucked up UV coordinates. My god. But we fixed only old stone. We didn't fix the lava stone. So actually we fixed the lava stone. And it's just as simple as replacing 0 with 1 in single place. It's one character bug. A freaking classic. Look at that beauty. Look at that mother flipping beauty. You know what? I kind of want to like increase the resolution because it's kind of too blurry for my taste. Yeah, kind of too blurry for my taste. And all of that is not OpenGL, so that's what makes it cool. It's not OpenGL. Holy shit. It's just like, it's pixel by pixel from freaking scratch. So cool. And because of that, we can actually run all of that stuff in a terminal. So let's actually see how it looks like in a terminal. Right, I'm really curious. Okay, so and then we can do triangle. Triangle 3D texture terminal, right? Well, I mean, yeah, okay, so what did I expect? It's just interpolated some colors and stuff, but it tried. It kind of, yeah. Maybe we should increase the resolution specifically for the terminal. Alright, so remember that for the teapot, we just had to set the scaling a little bit higher. Alright, so let's actually set the scaling a little bit higher so the texture becomes a little bit more visible. No gel trend, let's go, exactly. Damn, look at that. Well, it's having a little bit of a hiccup, but overall. It's kind of cool. It's a terminal, right? It's ASCII stuff, basically. Where do I start if I want to become a master programmer like you? Keep in mind that I have 17 years of software development. Basically. 16, 17, I don't remember precisely, but... Are you ready to take that path? Do you have enough patience to walk that path? Here's the thing, it's not about the destination, it's literally about the journey, really. Right. Because if you make it about the destination, you will run out of patience very quickly. Because there is no destination. Have you ever qualified for ACM ICPC? I have seen you wearing... Yeah, so I've been on semifinals for my region. Northeast something, near, I forgot what it is. ACM ICPC near. What was that? North Eurasia yes, North Eurasian semifinals. But I never been in the finals, only semifinals. I'm not really that good at competitive programming because I get stressed out really easily and yeah, I can't focus. So I can solve pretty hard competitive programming problems, but only when there is no pressure on me in terms of time or whatever, right? So usually if I just sit down in a comfortable environment, I can pretty much solve it. But because I'm easily stressed out under the time limitations, I was never good at actual competitive programming. So what's interesting is that competitive programming is really not about like how good of a programmer you are. It's more about the stress management, at least for me, right? Really bad at stress management. Why there are white edges around the purple trees? I have no idea, honestly. I was just avoiding that problem, thinking that maybe it will go away, but it didn't go away, apparently. But we don't really see them in here, right? It could be because of how we... Oh yeah, I know. Okay, so the way we resize the frame before putting it in the terminal, we actually resize it by chunks, right? So we take a chunk of how many, like 32 by 32 pixels, or it depends on resolution. We just take a small chunk and we compute the average color for that chunk. And that color becomes the color of one character in here. So one character is a cluster of pixels, and the color of that character is the average of those things. So this is how we resize specifically for the terminal demo. And if the cluster is on the edge, it computes an average of these colors and these colors, and these colors become more like diluted with whatever we have in here. This is my best explanation I can come up with. I think this is roughly how it works. But maybe I'm wrong, but I'm just too lazy to go into exploring like why it is like that. So something went wrong. Yeah, I should have not closed this thing. We'll make Doom in terminal. I don't know. I'd rather create my own game. Here's an interesting thing. Like, somebody makes a Doom, or let's say Tetris, right? And everyone is super impressed about that. But what does it mean to make Tetris when Tetris was not a thing? You know what I mean? So it is easy to make a game when the concept is already developed for you. You know what I mean? So the concept of Tetris, for instance, is already well developed. You only need to take this concept and implement it. But what does it mean to make a concept as cool as Tetris, or make a game as cool as Doom? That's, for me personally, that's what's actually interesting. You know what I mean? Make a Doom. I mean, Doom is already made. There's nothing interesting in making Doom. Not sure if it makes sense. It's just, it's a very subtle difference, right? Anyway, what I want you to do, yeah, I want you to increase the resolution. I want you to slightly increase the resolution of those things. So you know, I'm gonna call this thing origin, and this thing origin. And just get rid of that stuff, and then we'll build. CP is a competitive programming. I'm confused whether I should focus more on CP or development. Focus on both. They're both fun, actually. But just keep in mind that they're basically different activities. Okay, so maybe I should actually rebuild everything just in case. So let's rebuild everything. To be fair, I mean, I think in the future competitive programming is going to be dead because of the GPT models. Because look, codeforces.com. Where's HTTPS? Mike Mirzayanov, what the fuck? Anyway, so this is a huge base of problems, of competitive programming problems, right? So there's like thousands of them. And look, you can click here, right? Here are submissions, people who are trying to solve these problems. You can click here. You can click here. Okay, can you click here? But anyway, I think, hey, is it because something's wrong? But essentially, if you log in, at least, there should be a solution in here. So we can actually take solutions. Solutions are open. Take this entire shit and feed it into the GPT model and see what's gonna happen. I'm pretty sure they're gonna basically kill competitive programming as an activity, the same way as like AlphaGo killed Go or something like that. So yeah. So you have a huge database of things to feed into the language model. And the competitive program problems are like very well defined, that it's, I think, relatively easy to make a, you know, a model that can just like, you know, crank them very easily. Okay, so let's continue. What I want you to do is increase the resolution of my textures. Right, so they are 120, let's actually do 200, right? So I'm going to convert old stone origin PNG and then old stone PNG, and then just resize it to 200, right? But it was lava stone. What is going on? Compilation process is running. Why is it running? Okay. Lava stone. I wanted to see the file. It didn't work, even though... Oh, because I did old stone. Okay, so let me take a look. This is... okay, so that's a bit better. And let's do the same for lava stone. Lava stone. Okay, so if I take a look at that, seems good. And I'm gonna do another nobuild thing. Have you ever worked in game development company in Korea? No, never worked in game development. Alright, so let's continue. What I wanted to do, I wanted to just refresh this entire thing. Does it look better? I think it looks better, so it has more, yeah, more details. I really like how it looks like. Why not? Because I value my health, physical and mental. Do you know what it means to work in game development, especially close to the deadline? Do you know what it means? Just no. I'm not participating in that bullshit. Okay, so triangle, right? Okay. I really like how it looks like. It's kind of cool. Though the background color could be a little bit bright, I think. We have a background, so I think it's Olivet's feel. Let's actually make it just a tiny bit brighter, like 20. And let's just go build. Okay, that looks much better. Look at that, look at that. And this is not OpenGL, even though nobody gives a shit. Right. Can you understand how game developers have so much passion to justify so much exploitation? That's a good question. I don't know. I would probably say that maybe it's because it's a young developers, right? So, but look at John Blow. He's like 50 and he's still working his ass off. That's how passionate he is about game development. It's just like, it's not about the age even. It's just like, it's a pure passion. I just like don't have that much of a passion towards game development, right? It's an interesting problem to solve, but yeah. It's 52, I think, right? Something like 52, if I'm not mistaken. Some people maybe enjoy creating games and they don't mind. Oh yeah, maybe that's basically continuation of me not being able to work under pressure, right? Because I was never a good competitive programmer because it's too much stress, and for the same reason I don't like a stressful job, right? So that's probably why I don't work in game development, even though I might have all of the necessary skills, technical skills to work in the game development. I lack, I think, what's the pretentious word people use to describe that? Soft skills, right? I forgot soft skills. I don't have soft skills to work there, right? So that's the word. Anyway, so, and it's not even skills. I think it's not even skills. It's more of a biological thing, right? So I'm biologically not built to work under huge stress. I think because I tried a lot. I worked at different works and it's just like, yeah. If I'm under pressure, I just like can't fucking do that. No, fuck that. I'd rather be poor my entire life, right? Live in a ditch, but if there is no pressure on me, I'm gonna be happy. Right? So, some interested people can't work because there is maths. Oh no, not because there is maths. Because they think there is math. If you take those people who say that they're scared of math, and you show them something interesting, but you don't tell them that this is math, they won't be scared of that. So the fear of maths is actually artificial, that is imposed by education system, right? The modern education system basically presents math as shit ton of pointless rules to remember to solve problems that you're never gonna have in your entire life. This is how modern education presents mathematics. This is how it presented. And of course, if you study that shit for several years, you're gonna be so sick of it, you will be like literally avoiding that your entire life. If this is what you think is math, which in reality it is not. Mathematics is not about that completely, but it's already too late. Like, right, so educational system basically traumatizes people, and this is actually kind of dangerous for the humanity. And I know that it sounds pretentious, but it is dangerous for humanity because we have an educational system that produces people who don't want to do math, and we are heavily dependent on people who do math. Right? That is actually fucking dangerous if you think about it. Right. So imagine the entire system, our entire infrastructure is dependent on people who understand math. But our educational system produces people who are afraid of math. That is dangerous. Alright, anyway. So, what I wanted to do, I'm gonna actually commit all of that. Alrighty. So I'm thinking about the commit message, right? So what I'm gonna put here as a commit message, I think I know. Port bilinear interpolation to triangle functions, right? The triangle functions, and let me rebuild everything one more time, just in case. Okay. nobuild, build everything. But what's interesting is that majority of people probably not gonna use math anyway. At least the math that is given to people, right? So when was the last time you needed like integral? Anyway, so we can talk about this forever. Let me actually run the tests. It's a single test. Alright, so everything seems to be working, and let's do the update wasm binaries. Update wasm binaries, and let's actually push that right to the bottom. Okay, I really like how the texture thingy looks like. It's so cool. Though now it looks lame because the background is actually... Okay, so let me bring the background back. Let me bring the background back. So it was a demo, text, 3D text, 2020, query place 2018, boom. Let's rebuild everything. I go to work every day thankful that I know the definition of derivative. The definition of derivative, by the way, is really cool. It's kind of like non-intuitive. Right. It's just like you basically start to explore, right, what is going to happen if you start narrowing, right, the value of the function and the input of the function divided by each other. And you would expect that it will arrive nowhere, but it actually arrives somewhere analytically, and it's just like, what? What the fuck? How did that happen? And it's rather interesting, and it's actually kind of makes sense and has a huge application. So yeah. Alright, that's good. Bring back old triangle 3D tech background color. And let's push that right into the repo. Yo, that is cool. That is very, very cool.